Morning class. So I hope you guys are enjoying your days and your week off. If you're in school, if you're taking tests, I'm hoping you guys are doing well on every exam or every midterm or whatever you guys are doing while you guys are off. Um, Today I'm going to cover lesson 5.3, which is the last of the three methods that we're going to learn regarding systems of equations. And I really hope that you guys have been watching the videos as well as taking notes and beginning to work on assignments. I haven't seen any questions yet pop up in the Google Classroom page, as well as no remind messages saying, "Hey, Mr. Wolford, I don't get this." So I'm assuming that we're all on the same page. I'm going to send out a couple more reminder messages, as well as some things on Google Classroom, just to try to get you guys moving. If you know somebody in your classroom who may have not touched the packet, please do them a favor. Just text them, say, "Hey, did you work on Mr. Wolford's packet yet? Please get it done." All right. I've been here. I've been planning, working on different things to try to make sure our end of our school year, these last two quarters, are fun, are engaging, as well as that we're able to decorate the classroom with different things. So let's dive into what we're going to be doing today. So we're going to be talking about Unit 5.3. Please have your packet as well as extra paper if you need to take extra notes, as well as something to write with. Let me just recap over what we have done so far. So we have talked about two methods so far. We talked about the graphing method. We talked about the graphing method, which is pretty simple. It's straightforward when it comes to systems of equations. You graph two lines, right? You see there's a blue line, there's a green line, and then wherever they intersect, that is the solution. Right? I think I mentioned it yesterday in the other video that there are three different types of solutions. There is one solution, like you see here. There are no solutions where they don't even touch at all. And then there is also where they have infinite solutions, which means that the line is pretty much the same exact line. And we'll see that as we go through this week coming up. And then the other method that we went over was something called the substitution method. So we're given two equations, and we solve for one of them. Like in the first one here is to actually solve for y is equal to this expression, x minus 2, and we substitute that in. We substitute it into the second equation. So instead of writing x plus y, we're going to write x plus x minus 2 equals 4. Now we do something called CLT. We combine like terms. We get 2x minus 2 equals 4, and now we solve. So in the green is solving for x. We get x equals 3. But now we have to make sure we go back in, we plug in to find what y is. When we plug it back in, we get y is equal to 1, and our solution to that one is 3, 1. So these are the two methods we have gone over so far in the videos that I've sent out, as well as on the packets that you guys have at home. I'm praying that you guys are working on it. That way when we come in this week, we're able to go full force into reviewing them, because I was going to give you a quiz, but I'll consider this packet a quiz. And then what we'll do is we'll go into, doing a couple activities, some word problems, systems of inequalities, and we'll be done with this unit. But I'm really excited to go over the final method today, which is called systems of equations using the elimination method. So please be ready, be engaged, and let's get started. So, hi, how are you guys doing? Once again, you should have your packet, something to write with. We should all be on page 7. So I'm hoping you guys are all up to page 7. And all you have left to do in this packet is page 7, 8, and 9. And that's it. And you should be done. So today you can finish up the whole packet and you should be set to go. So let me go over. This normally starts off with a belt work, as we do in class, just to get us all started, get us ready. The belt work is asking you to solve these systems using the substitution method. So I'm hoping that we was all able to use the substitution method to do it. At this moment right now, I'm actually going to, I would like you to pause the video if you haven't. Take a second, knock out the belt work, give it a shot, and then what I'll do is I'll go through it, right? If you don't want to go over and go through it, I will put as a like a reference in a little while the actual number you could skip to, so that way you could be able to say, okay, forget, I don't want to watch him doing it. Let me just make sure we got the same exact answer. Let me skip to this time in the video to make sure we got the same answer, okay? So take a moment, pause it, and begin to work on it. All right, so I hope you paused it, and I hope you had a chance to work on it. Let me go over it with you, and let's see if we both arrive at the same answer. So looking at belt work A, right, it starts off with negative 9x minus 4y equals negative 50. X minus 4y equals 10. All right? I'm going to take off my glasses just because right here, I may need them, but over here, it's too close. So let me go over how I do this. So if I'm looking to use the substitution method, I need to solve for a variable, right? I'm looking for that lone variable, either x or y has to be by itself. Now, out of these two equations, I'm going to solve for x in the second one because I see that x is a coefficient of 1. And as we talked about in 5.2, I'm looking for the variable with the coefficient of 1. So I'm going to solve for x in the bottom one here. This is going to give me x is equal to 4y plus 10. Right? What I did is I moved the 4y over. It became positive now. Now that I know what x is, I'm going to substitute that into the first equation. So this right here is going to now be whatever I see x is into the first equation. So if I go back to the first equation, it's going to look something like this. Negative 9 parentheses 4y plus 10 minus now 4y equals negative 50. Did you see what I did there? Right, I substituted in. Right, I substituted in the value for x as 4y plus 10. And every time I see an x, I put 4y plus 10. Now I have to use the distributive property, where I'm going to distribute the negative 9. And now I should be able to simplify the left side, and my goal is to solve for y. After I solve for y here, I can plug that back into x here and solve for x, okay? So I'm going to distribute. You should get negative 36y plus 10. Nope, I lied. Oops, so sorry. So negative 36y minus 90, right? Minus 90, right? Then we keep writing the rest. Minus 4y equals negative 50. Remember, I'm not going to distribute the negative 9 to the negative 4y because it's not next to it in parentheses, right? That's over on the other side. So now I can combine like terms. So negative 4y, negative 36y gives me negative 40y minus 90 equals negative 50. Combine like terms, right? I'm going to add 90 to both sides now. When I add 90 to both sides, I should be able to solve for y by itself. So I'm going to add 90 to both sides. When I add 90 to both sides, 90 cancels out. I get negative 40y is equal to 40. Right? Now I can solve for y. All I have to do at this point, I'm hoping that you have done it as well, is divide by 40. Divide by negative 40. I apologize. Divide by negative 40 because you want to get y by itself, not negative y. Right? And you end up getting y is equal to negative 1. You get y is equal to negative 1. As I said before, after you get that, you go and you plug that back in right here. And now you should be able to tell me what y is. You should be able to tell me what x is. So now instead of writing y there, I'm going to write a negative 1 plus 10. So now 4 times negative 1 is a negative 4 plus 10, right? Negative 4 plus 10 is a positive 6. So I know that x is equal to a positive 6. So my solution in this case is going to be 6 comma negative 1. Remember, x always goes first. So x is the first number, then it's y. Okay? So this is my solution right here. All right? This is my solution. I'm going to write solute. All right? Now I write the whole thing. Solution. Okay? The solution here is 6 negative 1. All right? I'm hoping that you also arrived at that. Let's work on the second one here. Okay? Once again, if you already got this and you're like, you know what, I got this, now you can skip forward again. Skip forward to that timestamp that I gave you earlier, okay? So looking here, right, what I could do is say, oh, in the first one, the y has a coefficient of 1. Since the y has a coefficient of 1, I'm going to solve for y. I'm going to change this and make this look like y is equal to 6x minus 8. How is this green? Is it showing up? Okay, great. So y is equal to 6x minus 8. I moved the negative 6x over by adding 6x to both sides. It canceled over here, but it became a positive 6x over there. So now that I have what y is, Once again, I'm going to say wonderful. Now I'm going to substitute this in here every time I see a y. Every time I see a y. So I'm going to write the bottom, negative 6x plus 8, right? Now it says 8y, so instead of writing y there, I'm going to write 6x minus 8, right, is equal to negative 22. Right? I should have changed colors. It didn't. Okay? Now I have to use the distributive property here, so it's going to give me negative 6x, right, plus 48x minus 64, right? If you're like, how did he get those numbers? What did he do? I distributed, right? I distributed here, all right? I don't know why the colors aren't switching up. I distributed here, and I distributed over here, right? 8 times 6 gave me 48x. 8 times negative 8 gave me a negative 64, right? So now that I have the numbers there set up, I can go, that equals negative 22. All right, remember what we did before. We do combine the like terms. So like terms here are these two. These are CLT. This is for me to combine like terms here, right? So negative 6x plus 48x, right? That gives us a 42x. It's a positive because the 48 was positive, right? So that's 42x minus 64 equals negative 22. Now I add the 64 to both sides because I want to get all the numbers on one side, keep the variables on the other side of the equal sign. Right? That cancels out. I end up getting 42x is equal to, right? And if you add these two numbers together, what you end up getting is actually 42. Right? You end up getting 42 over there. Okay? Then I divide by 42 on both sides, and we get that x is equal to 1. X is equal to 1. All right? Once again, after you solve for x here, you're not done because you need to find a solution, which means you need to go back in and plug in that x value into up here. So now I'm going to plug in 1 every time I see an x. So when I go back up here to the top, it's going to be y is equal to 6 multiplied by 1 minus 8, where 6 times 1 is 6, minus 8 gives us a negative 2. So our solution in this case here, right, if we're looking for our solution is going to be x first, which is 1, comma, y, which is negative 2. So that's what you should have arrived at over here as your solution, right? So over here, the solution would have been 1, negative 2. Okay, I hope I didn't lose you. I hope that up to this point, as you're checking your answers, if you jumped ahead, that you would have got 6, negative 1, and you would have got as your solution over here 1, negative 2. Now, if you didn't get those answers and you want to go back and say, well, how did Mr. Warford get it? Please go back and watch as I did A and as I did B of the bell work, so that way you can understand, wow, that's how we got a solution. All right, let's go on to the part that I want you to learn for today, which is the method of elimination. Okay. Looking at the elimination for A and B, right, in the modeling, do you notice that the equations for both A and B here are the same equations as we just did in the bell work? Right, they're the same exact equations, both of them. This is on purpose. This isn't accidental, right? This is on purpose because the thing is this: no matter what method you use to solve a system, which, let me refresh your mind, a system is 2 or more equations, right? A system of equations is 2 or more equations. So no matter what method you use, whether it's graphing, substitution, or even elimination, which you're about to see, you should arrive at the same solution. So if we said the solution for the first one was 6, negative 1, that should not change whatever method we do. If we were to graph that, it should still tell me that the solution is 6, comma, negative 1. And that's the same thing I'm going to prove here when we use elimination. That no matter what method we use, the solution should still be the same, right? So we are going to find the solution using this different method, right? And what I want to do is this. The elimination method is in the sense that what we're going to do is we're going to either add or subtract the two equations together. Now, I like the word add them together, but I know a lot of other people and places, they teach subtract them two together, right? I'm going to use probably both. Whichever one you decide is more comprehensible to you, please do it. And I'll try to, as I go through them, let me see which one I think is easier for you to understand, and I'll say go about that method. However, the one that I wrote step by step right underneath this, right, it uses subtraction, as you can see here. It uses subtraction, which is not bad, but I need you guys to remember, if you do subtract, you need to make sure that subtraction carries to each component of the actual of the second equation, and I'll show you what that means. Like, what do you mean, Mr. Wilfred? So first, we're going to multiply each equation by a suitable number, so that the two equations have the same leading coefficient, either in the x or in the y. They need to have the leading coefficient the same, either in the x variables or in the y variables. Okay. If they both already have the same number, right, 6 and 6, then you don't have 6x on the top and 6x on the bottom, then you don't have to multiply by anything. They already are set up to allow you to just subtract the bottom one and cancel out the x's. Okay, your goal is to cancel out a variable. Either you're going to cancel out the x's or you're going to cancel out the y's. Either one. Okay, you're going to subtract the second equation from the first. Okay, which that means you need to distribute. Make sure you practice distributing. I think I'm going to go with the subtraction method because that's what I wrote here for you. And I think it's good practice for you to practice distributing the negative. Okay, solve this new equation for y. Right, because you're going to solve for y or solve for x or solve for whatever variable you have left. If you canceled out the x's, solve for y. If you canceled out the y's, solve for x. Okay, and then you're going to substitute that number that you solve for, whether you solve for y or you solve for x. Now you're going to substitute that in to the one of the equations. Doesn't matter what equation, whether it's equation 1 or equation 2, just substitute it in and solve for the other variable, whether it's x or whether it's y. I'll show you what we mean. All right, so for example, right, we know the solution to this, right? So I'm going to solve it using the elimination method, and it should still give me the same solution as we just got. But what I'm looking at here is I see I have negative 9x minus 4y is equal to negative 50. The second equation is x minus 4y equals 10. Now, when we say we need to make sure the leading coefficient is the same for one of the variables, right, look at the coefficients, the leading coefficients of these variables. X here has a negative 9 leading coefficient. Y here has a negative 4 as a leading coefficient. When I go to the bottom equation, x has a leading coefficient of 1. So these do not have the same coefficient, right? We need to make sure they have the same coefficient. That is our goal. When I look at y's, oh, hold on. This y down here has a negative 4 as a leading coefficient. Negative 4 is the leading coefficient here. Whereas the first equation also has a negative 4 as a leading coefficient. So they both have the same leading coefficient, which means, wow, since we have the same leading coefficient, that makes both of these equations, that means that we are able to go to the second step. The first step is to make sure they both have a leading coefficient, the same leading coefficient. It doesn't have to be of y. It could have been of x. Right? I could have multiplied this x down here by a negative 9. But if I multiply this x by a negative 9, I got to multiply the y by a negative 9. So this negative 4 will be now a positive 36. And then I'll have to multiply this 10 by a negative 9, which means that this would be a negative 90. Right? So instead of me multiplying and getting all those big numbers, I say, hold on, the y's have the same leading coefficient. How about I cancel out those? Let me cancel out those. So let me rewrite the problem so you can see. I'm going to write both of the equations, and I'm going to show you what the second step looks like, which the second step tells us to subtract the second equation. So let me show you what, I'm going to rewrite it, and then I'm going to show you what the second step looks like. Negative 9x minus 4y equals negative 50, right? I'm not changing anything. That's the same as the first one up there. X minus 4y is equal to 10, right? Didn't change anything. I just know that, wow, look here, this is beautiful. They both have the same leading coefficient, negative 4, negative 4. They both have the same leading coefficient, which means that now I'm in the position to do the second step. I'm able to do the second step, which is subtract. I'm able to subtract now. I'm going to subtract by a negative. Well, I'm going to subtract by a negative, right? So when I subtract by a negative, let me show you what that looks like, right? So I'm not going to subtract by a negative. I apologize. I'm just going to subtract, right? It's going to look like I'm changing things, right? So when I'm going to subtract the second equation, right, I'm going to subtract it from the first equation, right? But notice this. When you subtract something like this, it has to distribute this negative on the inside. Everything needs to be affected. So everything here will be affected by that negative, right, on the outside, or that subtraction. Right? every piece. So instead of it being x minus 4y equals 10, it's actually going to turn out to be negative x plus 4y equals negative 10. Now, notice I'm using a lot of space here, and the only reason why I am is because, honestly, I want to make sure you're able to see it. Now, if you can make it more condensed on your paper, that's wise. That way you don't use up all your space, okay? Right? But I have negative x plus 4y equals negative 10, okay? When I go to rewrite the first one here, right, I rewrite the first one, negative x minus 4y equals negative 50, okay? All right? Now what I see is this, right? Even though I subtracted the second equation, when I subtract the second equation, it turns all the signs into opposites. So when the x is positive, it turns negative. The negative 4 turns a positive 4. A positive 10 turns a negative 10. Remember I told you that there's two ways people teach it. They can subtract it, which makes sense, but I like the idea of adding. So after you change the second expression now, to make sure you have opposites, notice that these two are opposites. That's our goal, right? Our goal is to make sure they are somewhat the same at first, but then they eventually turn into opposites. One is negative, one is positive. Because now when I go to combine them together, when I go to add them together now, when I go to add them, this is what happens, right? This is what happens, which is what we want. This is going to cancel out. Because negative 4 plus a positive 4 is going to give you 0y, which 0 times anything is just 0, so it doesn't matter anymore, right? So now what I end up getting when I add these together is I get a negative 10x. That becomes 0 is equal to negative 50 plus negative 10 gives me negative 60. Negative 60. Okay? Now, in order for me to solve for x, I need to divide by negative 10. So I'm going to divide both sides by negative 10. I think this part here is easy because I know we know how to solve for variables. This is the part that I want you to get, right? Which I'm going to repeat again in the second the second modeling problem. But you take your time, you rewind the actual video, get the understanding of what are we doing. We're looking for the same number, but then when we subtract it, they should have opposites. They should have what I'm looking for. One should be positive, one should be negative, right? The actual I'm trying to think, what am I talking about? Symbol, the symbol in front of it. They should be opposite. One should be negative, one should be positive, okay? So when I go to divide by negative 10, I end up getting x is equal to 6. I end up getting x is equal to 6, which is awesome. This is great. This works for us. Because now that I have x equals to 6, I can do step 3, right? And step 3 says, now that I solve for either x or y, because it doesn't have to be y, it can be y or x, either one, right? Now I go and substitute that in, whether it's y equals a number or x equals a number, into the other equation. So substitute it into either equation. So in this case, I'm going to substitute it into the bottom one. I'm going to substitute it into the bottom, right? I'm going to use the color blue as my substitution, right? And I'm going to do it up here so you can see it. So 6 minus 4y, because I don't know what y is, I only know what x is. So I changed x to 6, equals 10, right? Equals 10, right? Now we have to solve for y. I subtract 6 to both sides, right? When you subtract 6 to both sides, right, what do you end up getting? You get 4y is equal to 4, right? 4y is equal to 4. I'm sorry, negative 4y is equal to 4. Now I divide by negative 4, I get y is equal to negative 1. So my solution down here says the solution has to be 6, negative 1. Is that the same solution we got up top on the first one? Yes, it is. They both are the same. 6, negative 1, 6, negative 1. Okay? So you should end up getting the same solution. It wouldn't change the solution if you use either method. This method here, your goal is to cancel out a variable. Either cancel out the y's or cancel out the x's. Let me do one more with you, okay? Let me do one more. Okay? So when I go over here, I have two equations. Negative 6x plus y equals negative 8. Negative 6x plus 8y equals negative 22. I need to cancel out a variable. Now, in this case here, yes, the x's, they have the same number, which means if I subtract the bottom one, this will become a positive 6x, a negative 8y, and a positive 22, and then I'll be able to cancel out the x's. Yes, right? That's a fine method. You can definitely do that. But for the sake of the first step being understanding, well, why would we need to multiply? Let me show you why we need to multiply. Imagine if these numbers weren't the same, right? In this case, right now we do see there's a negative 6x on the top and the bottom, so that means that we do have the same number there, which is awesome, right? But I'm going to show you how we multiply if I had to multiply to cancel out a variable. Let me cancel out the y's again. I'm going to cancel out the y's, right? So the way I'm going to cancel out the y's, I'm going to actually try to get this y up top and the y on the bottom to have the same coefficient. Let's have the same leading coefficient. So the top number is 1. The bottom number here is 8. That means I need to multiply the top by 8 in order for me to have them both be 8. So I'm going to say, okay, the top here, I'm going to multiply this whole thing. So that's negative 6x plus y equals negative 8. I'm going to multiply that whole thing by 8. I'm just going to write the bottom one here the way it needs to be. Plus 8y equals negative 22. Okay? When I multiply this top one, right, when I multiply the top one by 8, I end up getting a negative 48x plus 8y equals negative 64. Equals negative 64. So I multiplied everything by that 8. Remember we talked about the distributive property, right? I distributed this 8 to everything inside this parenthesis. Now I know you didn't see parentheses originally. I put them there. But you need to make sure if you're going to multiply everything in that equation, not the second equation, everything in the first equation, if you're trying to multiply it to get these two to be 8, they both need to have, everything needs to be multiplied by whatever number you're trying to multiply that equation by. Okay, so I'm going to write the second one down here again, negative 6x plus 8y, and wow, they both have the same y value now. This is beautiful. They both have the same y value, right? They both have the same y value. So now I can go on to step 2. Step 2 is telling me subtract. Subtract the second one from the first one, right? When I go to subtract the second one from the first one, right? Remember, we are going to change all the signs. All the signs are going to be changed, right? I'm going to do this step just a little quick, just so you can see it. But when I try to change this sign, it's going to become a positive 6x now, right? Positive 6x added to a negative 48 gives me negative 42. Right? Gives me negative 42x. Okay? The negative 8y plus 8y, this is going to cancel out. And we should see that and say, oh, yes, this is going to cancel out. This is definitely going to cancel out. That won't work anymore, right, when we subtract it. So that will equal 0. When I go and multiply this subtraction by the negative 22, it becomes a positive 22, which leaves us with a negative 42 over here. Okay? So now we have negative 42x is equal to negative 42. We divide by negative 42 to get x by itself. And just like we got up there, we said that x is equal to 1. Last step, we go and we plug this in to one of the equations. It doesn't matter what equation you plug it into. Plug in x equals 1 into one of the equations. I'm going to plug it into the first one, honestly. All right? When I go to plug it in, I get negative 6 multiplied by 1 plus y, because we don't know y, equals negative 8. 8. That's an 8. That's an 8. Right? Negative 6 times x, which is 1, plus y equals a negative 8. So now I got negative 6 plus y. Oh, this thing is acting funny now. Equals negative 8. Add 6 to both sides. Right? We end up y is equal to negative 2. Our solution here is 1 comma negative 2. And then voila, we check to make sure that's the same as what we got up here. And it looks the same. Awesome. Okay? So this is called the elimination method. Your goal is to cancel out. Right? Your goal is to cancel out at least one of the actual variables. Now, yes, I could have canceled out the x's right away here. I could have canceled out the x's, and I would have got a negative 8 plus y, which would have gave me a negative 7y. And I would have had a positive 22 with a negative 8. And that should have gave you, what, 16 or something like that, right? You would have been able to see, wow, okay, I got 7. This would have been, sorry, let me just double check my math. That would have been 14, all right? Yep, that would have been 14, okay? You would have got 7y with the positive 14, okay? So something like that. Negative 7y with a positive 14, divide, you would have got y equals negative 2. Then you would have to plug it back in to get x, okay? So these are the steps of elimination. I would suggest you rewatch the video, practice a little bit. You have a lot of practice. You have page 8 and 9 to practice regarding the elimination method, plus you have delta math, all right? Master these 3, because when we come in on Monday, I know you guys are excited to be back. I got a great activity that we're going to do to get you guys up, get you guys moving in the classroom where you have to work in teams, right? And I also have a surprise for winning teams, all right? So be ready, watch the video. If you have any questions, once again, drop them below inside the Google Classroom slots, comments, and that way I'll get back to you. If you can't comment below, please, if you want to directly message me through Remind, you can do that as well. You guys have a great day. Enjoy your day. Bye-bye.